Glass fiber technology, Isolinks, all the questions. Michal is the expert.
Yeah, exactly.
All right.
Exactly. Thank you for introduction. I'm Michal, but you can call me Michael as well. So maybe it's easier. It's a typical Polish name, so don't bother to call me as you want. First of all, I'm structure engineer, so my approach to the products is from this side as an engineer, so I have to know how it is used, how it works, and then to sell product when I do understand fully the product. And my approach is from this side when I talk to the clients. And secondly, I'm a business development manager by Schöck Poland. I'm responsible for Polish and for the Scandinavian market in terms of Isolink. And Isolink is my baby. So I started the history of Isolink in Poland. Nobody believed this in product. I started the first wall, which was made in precaster, in the Polish precaster located in the North Poland, Gdańsk. I installed Isolink on my own, so it's also my baby wall, I would say so. And the history began that time. I didn't know that time anything about Isolink, but I knew that the precast world is growing, that it's this direction in which we have to go. And it's the future of the building in our countries, I suppose, in your country as well. When it comes to Poland, we built our approach to the building as the whole precast buildings is still small. It's about 5% of the whole buildings, but it's growing. The interest of the developers is growing this way, and the cost of the work is also growing. That's why they're heading this way. This way. We are going to talk about combar. Combar, it's a glass fiber bar material. It's a starting material for Isolink. Then we go to Isolink C, which is a material, a product which comes from combar. It is used in sandwich walls. And then we go to the new product, developed product, Isolink C-Y. Starting with combar. These are our range, beautiful picture of our range of products, especially this headed, ended bars and these bend bars. We specialize in these bend bars. Nobody in Europe makes that. It's a manual work, takes a lot of time, but the result is perfect. But first of all, I have heard yesterday that you are skeptic about glass fiber material in some way. I'm also skeptic. We have to understand in which applications we can use this material, because it's not that easy. When there was 2 years ago, we have a crisis with prices with steel in Poland, so I got a lot of phones and people asking to change steel into combar in plates, in beams and columns, and I had to say, no, it doesn't work in this way. Some properties is very useful for some applications, and we have to find this proper application to understand the material. And the first, and we say that is the biggest advantage of the glass fiber bars, so high load bearing or high capacity is not the way we have to find the proper objects. I explained later on the graph. But the next properties like corrosion resistance, like easily machinable, not conducting magnetic product. These are these properties which we have to use when we think about glass fiber material. But very important for us, for engineers, is to understand the first property and what is wrong with the marketing about the product. We see this graph which shows the correspondence between stresses and the placement. or deformation. So as we know, the tangent of the angle here, it's a Young module. So we see on the blue line, it's a comb bar, and red line, that the Young module is 3 times smaller than for steel. That means that we should design things on deflection, because the Young module has great influence on the stiffness of the element, so deflection is the matter in this way. Secondly, we see that the line of comb bar is straight. So the linear behavior of the glass fiber bars is different, unlike steel. We have yielding point in steel, and comb bar breaks. So it also doesn't allow us to use this plastic movement of the bending moment. So the plastic properties of steel. So we could only design one span elements, like one span beam, one span beams and plates, and 2 span elements is difficult to design with this material because it breaks. And that's why it's difficult to use glass fiber bars into load-bearing elements. Third point is that the fire protection or fire properties of the material is also very pure. That means that we need bigger concrete covers. And that have influence on the force arm. That means that we have to use more bars compared to the steel. So the most important thing, we say that tension capacities, as it's shown on the graph, is very high. It is, but it's short time capacity. We make tests, so we make the environment, special environment to simulate 100 years of usage of comb bar. And from this environment, we get the proper long-term capacity. It's like for normal steel. So in this way, there is no advantages compared to the steel. We can't use comb bar fiber bars in load-bearing, responsible elements. But as I said before, we have to use these other properties to find the proper way of using glass fiber bars. How it is produced? We have the production in Germany, in Halle. The production is divided into 2 stages. The first stage is pultrusion process. So we have the fibers which are packed very tightly together. The resin is put in, it's heated up, and at the end we have the straight bar. And the second stage is ripping and putting lacquer on that. And in the end, we have the straight bar ready to use, ready to install. Due to very tightly arrangement and straight arrangement of fibers, we achieve this high load capacities, and it has great influence on that compared with our competitors. But as I said before, it's still we are talking about long-term and short-term capacities. And this Young module. We have the stiffest, the highest Young module in Europe, but still we have to take in mind that this still it's 3 times, this Young module is 3 times lower than normal steel. The range of product, we produce bars in 6 diameters. As I said before, we have these carved bars. It's our patent on that. It's a manually work, so it takes a lot of time. So we prefer making headed bars instead of bending bars. It's better to use to make a cage using headed bars instead of stirrups. It's easier and then speeds up the work. We have additional things like plastic clips to make meshes and plastic spacers for making space between meshes and the bottom area of the scaffolding. And references. These are these properties which I showed before. These three properties. So it's easy to machinable, easy to cut. So it's a soft eye. So it's a starting shaft from the TBM machine in tunneling process. It's a drilling machine which goes through the starting wall. And instead of steel, we are using bars which are easy to cut. So the machine goes through the wall, and it's not destroyed by hard steel. Embankments, in which normally when we use steel, the corrosion occurs. After years, the whole concrete is destroyed by the corrosion products. So as you see, it's also not structure elements. One more sample of property used in combar. It's a tram changing elements for changing tracks, which current goes or current control the change of the tracks. And normal steel have influence on the current, so could stop the functioning or disturb the functioning of the current changing the tracks. And Isolink, combar doesn't have this influence. It's not magnetic. It doesn't have current doesn't go through combar, so it doesn't have influence. It can disturb the functioning of this stuff. And another one, it's measuring institutes, MRI in hospitals, and so on. So as before, the normal still have influence on measuring elements, measuring machinery. In this case, using non-conductive element is very good because it doesn't have influence on very fine measuring elements, so it doesn't have influence on the results of the measurements. And now Isolink, as I said, my baby, so I'm proud of this product. It's not that big range of products like it was shown before, only 4 types right now, but still first of all, it's a very easy product and very good product. The product speeds up the work in the precast plants, but it still is very easy. It's very easy to understand. We don't have this name PM and so on, so on, so on. So we don't have these big books to understand, to have lots of capacities, and that's easy to provide and to install. We have 2 lines of product. We also always use diagonal and horizontal anchor for sandwich walls. And on the bottom line, we have Isolinks with stopper. So we use only these elements with stopper because we have to be sure, or that allows us to be sure that we have the proper embankment of the Isolink into the concrete. When we go, or the stopper stops on the isolation during the installing, we know that is the proper embankment of the Isolink, is the proper capacity of Isolink. So this top line we use mostly in double filigrane walls with isolation inside. When Isolinks also the distance element, because in production of the double walls, twin walls, or double filigrane walls, we have 2 stages and we rotate the element. So the Isolink is also the distance element after the rotating the first layer of the wall. And as I mentioned before, we have this two possibility of making core isolated walls with Isolink. On the right hand side, we have typical sandwich walls in which we use, as I mentioned before, the Isolink with a stopper. We use horizontal anchor, which is C as H, and diagonal anchor for self-weight, which is C as D. So H is horizontal, D is diagonal. That is very easy to understand. On the left-hand side, we have typical double or twin wall or filigrane wall, in which we use these elements without the stopper. As I said before, it goes up to the end because it is the distance element for element walls. And thermal performance of Isolink, or generally of glass composites, compared to the stainless steel systems and black steel connections. As you see, the lambda value, it's very low compared to the other steel elements, and this performance allows us to not to make calculation of U value of the wall, to put additional delta UF value for point thermal breaks. So we don't have to consider this additional value of the thermal breaks. So even up to 15 pieces per square meter, we don't have to add this value to the U value of the wall. As you see on the lines, it doesn't disturb the lines of the temperature in the wall. But it's not the biggest advantage of the Isolink. It's the biggest advantage is for the precast plants is speeding up the installing compared to every other system for sandwich walls. Sorry, this direction. This is a typical cross section of the wall. Once more, the advantages of Isolink. So this quick installing process. I did it on my own. I have no experience in making walls, but we compare parallelly different systems, and I was the first finishing the installing without no knowledge and experience. And what it does, this is the most important thing for precast plants, because when you speed up the work, so during the day, efficiency of the production grows. So during one day you can make more walls, and that is the biggest point for the precaster. Not the thermal properties, but the speeding up the work. We have a special screw tool which should be there on the table. It's a special thing which you put, an easy thing, but you put this on the drill machine and you can speed up the work. You just drill in Isolink directly into the isolation body. Compared to other systems, we have less waste of isolation because we can put the isolation on the table, and afterwards we can install Isolink. Normally, when we have guitars on other systems, you have to cut the isolation to the elements. So in this case, we install afterwards, and we can use in the proper way the isolation. Because of the depth limiter, we have this easy control possibility that everything is installed correctly. If we know that when we know that this stopper is heading the isolation, we know that it's enough inside, and the encouraging length is proper. Before, when we didn't use these stoppers, we didn't know we have to measure every single one if the depth is proper. So it took a lot of time for all. Installing was easy, but then controlling and measuring was a time-consuming process. So in this case, It's enough to take a look. If every single stopper lays on the isolation, then we know that is perfect. We have all this product range is certified. We have right now ETA, so European technical assessment. We have a Polish technical assessment. We have Netherlands technical assessment, but I didn't mention, but we have also German technical assessment. So the product is covered. I also work with this product, make lots of tests. I work with our Polish approval body and make fire tests as well, because as mentioned before, for the material, it's not good. It's combustible material. That's why I made the one-to-one tests in the oven, testing how it behaves as the whole element. Not the single bar, but the whole element as a precast wall. So we have a Ray 120. So although the material itself is combustible, for the whole material, for the whole system, with a mineral wall on the bottom in the lintel, we have achieved these results. Thermal performance, so I mentioned that, but as I said before, it's not the main point. Only in one project in Sweden, the investor used this property to show the government that he's going to this direction to reduce CO2 output, but it's the only one for 9 years now, only one project. And we have, of course, the tools to design. So we can easily design Isolink using our Schöck tables or our software. And there are some examples of walls which we made so far, or have made so far. When I first went in 2017 in the precaster, the biggest one, which in Poland is Pekabex, I saw lots of walls, and my dream was to make a part of them. After 5 years, we made all of them with Isolink. So it's a big success. And the point is that they calculate the cost of work. When you don't calculate the cost of work, just compare material to material or solution to solution, we lose. But when people compare the production process and that we speed up the process, that we increase the efficiency of the process, only then we can win, and then also can win. So when I convinced the biggest precaster in Poland, they have five factories in Poland. We make almost every single wall that comes from Sweden, because they deliver these walls to Sweden. They specialize in these walls with bricks on the facade layer. So these are all made with Isolink. Different kind of walls with bricks on the facade layer. And this is a Polish precaster, also a very nice project. It looks very easy, but it was very complicated because we have 3 different thicknesses of isolation inside. So 3 different pair of Isolinks, diagonal plus horizontal, and with a big opening inside. So geometry, not enough place to place Isolink, so it was very complicated. But the facade is very nice. It looks very nice. And I don't have the building. Maybe later there's a building, the whole building. But it's also the precaster that makes every single wall with Isolink, because he also knows that we speed up the work. And he works on the Polish market, and he works on the German market as well. So we deliver from Poland to Sweden. We deliver from Poland to Denmark, to Germany, to Slovakia. So our Polish market is too small. So our precasters deliver even to Switzerland recently. So it's a bit crazy because the distance is huge, but we are delivering elements to Switzerland as well. It's the example of this element or twin walls or double filigrane walls, which are not very popular in Poland. They are starting just production and thinking about that. but it's not possible, or not that very easy to sell this product. It's a very popular product in Germany. It's a very popular product in Austria. They make basements with these walls. And but we in Poland and Sweden and Denmark, it's sandwich walls world. So it's not very common in Poland. But we did some projects in this with this implementation. So this 2-day process. In the first day, they made the first layer of the wall, and then in the second day, it's the first layer is rotated, and then it is put on the table again with the fresh concrete. So we have the gap, and the gap is for on the building side with the concrete. So it's stiffer than connection between sandwich walls. But I said before, it's not very popular. It's difficult to sell it. So maybe in the future. Recently we did some projects with this kind of walls which were built inside the building, not outside, but between the floor and the living rooms, because it speeds up also the work. And we have this. We have to check the thermal things also between the floor and the living spaces. That's why they're putting isolation inside. So we can't use not isolated walls anymore in Poland between these two places. Because of the difference in norms, in Polish norms, we have difference between temperatures between floor and in the living space. Sorry. These are the references which we made, buildings which we made, or walls which we made, to be honest. It's the very first project that comes from 2018. It was made in Sweden. Looks perfect. That time our Polish precaster PKBX made 100 walls with Isolink and 100 walls with other system because they were afraid of our system. So it was a bit crazy thinking, because still there are 100 of them with Isolink. So if you don't believe in product, why do you make the half of them with this product? But the history started then realized and recalculated everything. They checked with the stopper how fast they can produce walls and so on. And the history started with this buildings. And this year we made this building with Skanska and with PKBX as well. There are rotated walls. Painted in concrete, so they are green. It doesn't look green from my point of view. I don't know if you see that it's green. Very complicated walls. You see there's different thickness of the facade layer. Not enough place, because here is only 1 meter without any support. Another side 1 meter on a support, and it's rotated. So we didn't have enough place to anchor Isolinks, but we managed it. And I was on the building side. It's a visualization, of course, but I was at the building side. It looks perfectly. Now we are working on the biggest project in Sweden. It was designed in Poland. It is being made in Poland and delivered to Stockholm. It's about 10,000 square meters of sandwich walls. On the bottom we have walls with bricks. Here on the top, higher levels, there's no bricks. There are normal concrete layers, and then we have balconies with isocorp extra everywhere. So with lots of isolinks, lots of isocorps, and everything goes from Poland. There's a project in Denmark. with a Polish client as well. Very nice project. So these are my pictures. I took these pictures. I was there because I am trying to go there with my clients to make these pictures of reference objects and to discuss the production and installing to know what should we do in other way, or if there are any points that we should do better. And the buildings look beautiful. There is additional wood on this. And but you can see that it is precast. They don't hide this. They just trying to show that it was made from precast elements, and they are not ashamed of that. And this is the portal walls which I showed you before. It's a Polish coast. The buildings are very, very modern. The expectation of the investor was that the people from Germany come to Poland and buy these buildings, but they didn't come. So they started the first building and stopped at the first building. They wanted to build all of them, but the Germans didn't want to buy them. So that was the problem. But still the walls look very, 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 very nice. As you see here on the top floors, they are inclined. They are not straight walls, but the facades are inclined. So it was also very difficult because the isolation body was also inclined. So we have different length of the Isolink on different levels. So installing, producing, and to be sure that the encourage length, that we go deep enough into the facade wall was very difficult. So it was high controlled, and it looks perfect, I would say. So I'm proud of this. And this is one building in which the precast plant used the double or twin walls. That everything was made of twin walls. So it was concreted on the building side, but delivered as a half prefabricated element. Only one reference, and then they stopped to do this because it was too expensive, to be honest. It was easier to make this on site, to concrete this on site, than to deliver it as a half prefabricated element. But still, we have a beautiful reference near Warsaw. And now something about the calculations. We do have, as I mentioned before, we do have software. It's very easy software to make calculation with it. We have different kinds of walls. So we have the sandwich walls, we have element walls, we have freely supported, freely suspended facades, like in most cases for sandwich walls. But we have also supported walls, supported facade walls. So for me, it's very difficult to imagine this kind of walls for sandwich walls. But still, we have this possibility. So as you see, it's nothing difficult. Just put in some data, and you get the information about the drawing and information of the material, of the type of Isolink you have to use. We always say the naming of, as you see here, in the naming, there are two numbers. The total length of the Isolink is the first number, and the second number is the position of the stop. Everything depends on the thickness of the element wall, of the facade wall, how deep we can go. We normally leave 1 centimeter concrete cover. So if we, for example, we have 60, we always go 50 millimeters into the facade wall. So that's why we know what is the location of the stopper. And we have also a plugin into Tekla, and it works also perfectly. So people who use Tekla can easily speed up their work, just making calculations. It's a combined. This Tekla plugin is combined with or based on this software, but it makes automatically the calculation. But still, you have to put in some data in it. And now we are working on some other softwares or plugins. I know that very popular software in Scandinavia or in Sweden is Impact. I would say half of Sweden is working on impact. The second half is working on Tekla. So for Tekla, we have already the plugin for. We are working on plugin for impact. A new product in our range. It's Isolink C-Y. As you see, there is no. Probably you see there's no ripping along the bar itself. The ending is completely different, and due to this ending change, we have a higher resistance for concrete failure under tension load. So the pull-out capacity is higher compared to the normal Isolink, and we can with this Isolink we can make thinner walls. The installation is also very quick, even quicker compared to the normal Isolink, and it's the installation in pure elements is better compared to normal Isolinks. It speeds up the work in pure because pure is hard material, and this ending it's better works in drilling into pure. So that's we have already ETA for that. So European Technical Assessment. We are starting production next year. So we don't have any prototypes right here. Yes, we do. So we have prototypes of that, but as I said before, we have to start up. We are going to start the production next year. So it's everything from my side. If you have any questions, don't hesitate to ask questions. Or if you have, it wasn't a deep dive into the designing process. It's just showing you how it works with Isolink and what the properties of GFPR material. I think it's very good for engineers to understand and answer questions for the clients. Why not? Why yes? And if you have any questions regarding Isolink, I'm always there. You can contact me if you want to make a big dive. We can organize some meeting. So thank you for your attention.
You can do the question round already?
No. I open for questions.
I have a question.
Yeah.
About the combar material. Can you use it with any Eurocode for reinforced concrete?
No. According to Eurocode, no. No possibility. They are working on already. They are working on Eurocode, but according to any European approvals, as far as I know, there is some Italian norm according to which you can calculate, but normally it's very difficult to combine Eurocode and Italian code. It's very difficult to explain why you are doing this. Some calculations, especially when in tunneling, is made based on the American standards, because there are no regulations.
Because I think the Eurocode for reinforced concrete assumes that we use steel.
Yeah. Exactly. That's the problem. But still, as I said before, if you know the properties of the material and you see that you can make any load-bearing, to be honest, load-bearing elements or responsible elements like plates and like beams, double, three spans. It's difficult to say that it's a good material to use in these elements. Of course, I saw some bridges, but it was only one span bridge. There was no fire resistance. It was about corrosion. In most cases, the bridges plate is thick enough. So in this case, you can use combar. But also according to other norms, based on the American norms in most cases, or as far as I know, there are also Japanese norm as well. But still the problem.
And maybe I can add something to that one, because I
Yep.
published the next version of EC2.
Yep.
It's available already, and there is a part in for composite reinforcement.
Yep.
Also for carbon fiber.
For carbon, no?
Reinforcement, so you can design according to this standard. But the national annexes are still missing for all countries. But the rules for the design are already given there.
Give it.
It's a valid standard because it's the final version. So
Mhm.
in some years it's valid all over Europe.
Yeah, but these are only basic information, but still you have to understand the material, how it behave, to be pretty sure that you design it proper way. The danger is in this material is what I said before, the linear behavior. It just breaks rapidly. So normally when you design in steel, you have this yielding point, you have this plastic hinge, you are pretty sure that deflection grows, but still there is safety factor. Nothing happens. In case of comb bar, in case of any glass fiber materials, you have rapid break. So there's no chance to run away. So that's the problem in this material. So you can't design responsible elements, to be honest. And still, the price when you have when there is a fire. Let's imagine that we can redistribute moments, bending moments, plastic redistribution of the moments. So let's imagine that we can design 2 or 3 or more spans. But still, because of the fire resistance, or because the material is combustible, the concrete cover should be greater, double greater. So let's imagine that we have 3 centimeters or 2.5, so we have to double the number. So let's 70 millimeters or something like this. So with the same height of the slab, the force arm is smaller, so we need more bars. So the cost is growing. We are calculating with a small arm, the bending is growing. Also, we have 3 times less module, some young module. So the bending is growing. So we have to add additional bars. So at the end, we have 1 next to 1. So the costs are huge. So we have to decrease the prices, but the production itself for the good product is expensive. So it's very difficult to say what the price should be of what the price of the style should be, how high should it be to use GFPR bars instead of steel. So that's the problem. But for other applications, it's perfect. It is a perfect product. So I said before, Isolinki is my baby. I know the product from the very basics and go deep into the product. So I know everything. I was working on calculations, of software, on tests and so on. I'm working in a factory. In this application, it's perfect. In corrosion, magnetic elements, it's a perfect material because we can use fully these properties which steel doesn't have. But for designing, no.
What about the fatigue of those connectors?
Sorry?
Fatigue.
Fatigue?
Yes.
That's also the problem.
Yeah,
because it's stiff.
problem.
It's stiff. It's a stiff material. It's glass. So fatigue, yeah, that's a problem. But for Isolink, we did a test for fatigue.
And
So
what is the number of cycles of this connector takes? You don't have any technical data.
I have to look inside. I don't have this in mind, but I'm pretty sure I have this in my laptop. But we did this test, but we did test for Isolink itself, not for Combar, but for Isolink, because we know that the facade wall is working all the time, night, day, summer, winter, so it's shrinking or expanding. So we make this test, and based on this test, we have maximum dimensions of the facade wall because of the fatigue. But still, if we have the great isolation thickness, it's easier. But with the small isolation thicknesses, the fatigue is very important. So we can't make very long walls. But we did this test, but as I said before, only for Isolink. But it's true, that's the problem. That's the problem. So that's why the designing is not only some information, but you have to go deeply into you have to know much about this material to design. It's not that easy. No more questions?
Would you want to show us how you work in the factory and how the drill is? It means everything
You have this?
the adapter.
Ah, adapter. Ah, okay. So we can do this. Yeah, I know how to do this, so maybe someone who doesn't know, it would be better.
That's the new one.
The new one?
Yeah.
I've never tried it before. Often it works.
First time.
Okay. Already installed. Yep. So standard wall, let's say it's 3 meter high, 6 meter long. It takes about 5 minutes to install the whole Isolink for the whole wall. Compared to any other systems, it's a huge gap. Huge gap. So it causes that during the one day you can produce 4 more walls. So when you have a precast plant have a great number of walls, they can speed up the process of delivering walls. And I have one customer in Poland because they had other system. I won't give you the name of the system because it's our competitor, of course. But they have the traditional system which took a lot of time to be installed. And they were late with walls. They wanted to try because they read something on the site, internet site, that we are so fast. They didn't believe. So I came there. We made some tests, and they speed up the work. Of course, they were still wait. They had to pay in fines and so on, but not that high fines compared when they would go in the old system. And that point, they changed the approach to the solution of the sandwich walls, and they started production with us, and the whole production for sandwich walls goes with us because of this properties of Isolink. So not the thermal behavior, but the speeding up the work and the real point where the money is, not the thermal behavior I said before. So it's only marketing. It's not, it works, but in our reality, the thermal performance of Isolink is right now, it's only marketing. When we are going that deep in reduction CO2, it's the future, of course. But right now, it's speeding up and money. Yep.
Thank you very much.
So thank you for listening to me.